Today, we are moving into what we call the imaginary numbers. And you're thinking, why? Why do I have to learn about imaginary numbers now? Aren't real numbers sufficient? No, no, they're not. Um, when we started talking about imaginary numbers, like I took my other classes, I had them watch a video on imaginary numbers and the history of them. But ultimately, what they stemmed from is we needed to learn how to measure negative space. Everything back in the day, back in the 1500s, when mathematicians were like gods, they were like the rock stars of the time, because basically world powers were whoever was better at math became the world power, right? And so everyone was in this competition to become the better country or area or whatever they called them back in the day at math. Like duels were fought, people were killed. Like it was crazy to be a mathematician back in the 1500s. Um, and ultimately, what happened was they were trying to figure out how to measure negative space because everything was done in pictures back in the day. And there were all these question solves around cubics. And what they found out was that we could create this imaginary number system that helps us to figure in negative space. And what ultimately came from it was this an imaginary number system. It is part of the complex number system, but don't let the name fool you. It's not overly complex. Back in the day when we had problems like x squared plus 1 equals 0, which is kind of an equation we were working on before, right? We got this square, this x squared, and if we were going to use a square root to solve it, we would just move the 1 over, and we would wind up with x squared equals negative 1. And everything that we were working with on our next assignment would say, well, okay, if I have this x squared, I can just take the square root of both sides, right? And I should be able to solve this problem. So if I take the square root of x squared and the square root of negative 1, I'm going to get x right here equals, well, what is the square root of negative 1? Anybody know what the square root of negative 1 equals? It's a good guess, right? But the square root of something says that if I multiply something by itself, I'm going to get that number. What number can I multiply by itself to get negative 1? If I multiply 1 times 1, I get 1. What if I multiply negative 1 times negative 1, I still get positive 1. So those are both excellent suggestions, Daryl, and they would be the most obvious ones, right? But the truth is, there's absolutely nothing you can multiply by itself to get negative 1. And so, what mathematicians did is they created what's called the imaginary number. And what it says is anytime I have a square root, right, and I have a negative underneath it, I can pull that out as plus or minus I. And so what they determined is that I, lowercase I always, equals the square root of negative 1. And that I squared equals negative 1. This right here in this box is the most important piece of information you will get all day. Right? If you can just remember those two things, write them down, and remember that I equals the square root of negative 1 and I squared equals negative 1. what happens when we do this is called a pure imaginary number, is anytime I have a square root. So say I have the square root of -9, I can automatically pull this negative out as an I times the square root of 9. What is the square root of 9? What number times itself gives me 9? Exactly, 3, right? So our solution here is going to be plus or minus 3 times I. So it doesn't, the only thing that changes from what we were doing with square roots the other day is if you have a negative under the square root, you have to pull it out as an I. Everything else works the same, right? When we're talking about it in terms of square roots. If I have the square root of -196, I can say, well, that's plus or minus I times the square root of 196. 196 is 14 times 14, so it equals plus or minus 14I. Right? Will they always be perfect like this? Heck no. They're going to make you work, right? They always do. If I have the square root of -5 and I pull out that plus or minus I so that I have the square root of 5, I can't reduce that anymore, right? The only thing that goes into 5 is 1 and 5. There's no perfect square I can pull out of that. So this is literally the answer right here, plus or minus I times the square root of 5. If I have, just trying to think of some that are less obvious. Let's look at the square root of -32. It's going to give me plus or minus I times the square root of 32. But 32 I'm going to have to break down, right? Because we already know, like, you can, if you don't know it's divisible by 4, start with 2, right? So it's 2 times 16. You can look at that and go, well, 16 is a perfect square, right? It's 4 squared. So this is going to be plus or minus 4I, but we have to put that 2 back in. Does that make some sense to you? Nothing has changed in dealing with the square root once we pull that I out. We just have to keep the I. So it's the same process that we were doing in the previous lesson, right? When we were breaking down square roots. It's just now we have this negative under there, and all you have to do to deal with it is pull it out and it becomes positive, right? I call it plucking an I out because to me that's memorable. I don't know why. Probably because I have sons and they're kind of morbid. They like the idea of plucking eyeballs out, I guess. Will they always be this simple? No, you're going to get them in terms of equations too, right? Just like we did the other day when we were dealing with square roots. If I have, for example, x squared plus 81 equals 0, and I want to solve it, I'm going to isolate that x squared just like before by subtracting 81 from both sides. I'm going to wind up with x squared equals -81. And when I take the square root of both sides, I'm left with x equals plus or minus. What's the square root of 81? Forget the negative for right now. What's the square root of 81? What times itself gives me 81? So we're going to have plus or minus 9i. Thank you. Notice that each of these have two solutions, right? Plus 9i and minus 9i. Why is that? Because minus 9 times minus 9 also equals 81. Let's do another solving equation ones, and then we'll move into the powers and products. We have a lot to get through today. So if I have 4x squared plus 15 equals negative 9, we're going to start undoing everything that's being done to this x squared, right? We're going to work backwards with it, and we're going to start by subtracting 15 from both sides until we get x squared all by itself. What is that? 24, negative 24. And then we're going to divide this by 4 because we have 4 being multiplied to x squared. So we're going to divide by 4. And we're going to be left with x squared equals negative 6. And when we take the square root of both sides of this, I'm going to be left with x equals, to get rid of this negative, I'm just going to plus or minus I. And then I've got the square root of 6, but I cannot simplify the square root of 6, right? It's 2 times 3. There's no pairs of anything to pull out of there. It's 2 times 3 or 1 times 6. So this is as far as we can go with this problem. I kind of like this green color. So play with those a little bit. The next thing I want to talk to you about is the powers of I. And I think the powers of I is kind of cool. It's why I always like to teach it when I teach imaginary numbers, because you can figure out I to any power just by knowing really the first 4. So if I have I squared, when I told you some of the most important pieces of information we would learn today, was one that I equals the square root of negative 1, and that I squared equals negative 1, right? Let me erase this a little bit just to make myself a little bit more room. I, right, to the first power just equals I, right? So if I'm raising I to the first power, we never write the first power, but if we did, I to the first power would just equal I. I squared equals negative 1. Why? Because we said it does. We made it up. It's imaginary, right? I to the third power, well, that's like saying negative 1 times I. So that is just negative I. I to the fourth power, well, that's negative I times I. So that's negative I squared, which is negative 1, which just gives me positive 1. The crazy part is, if I do I to the fifth power, well, that's 1 times I, which is just I to the sixth power, well, that is just I times, I to the sixth power. I wrote it as I squared because it's going to be the same solution. That's the same as saying I times I, which we know is negative 1. I to the seventh power equals negative I. I to the eighth power equals 1. And that is going to repeat forever and ever, every 4, right? So think about this. How can I find I to the 27th power, or I to the 112th power, or I to the 278th power? I want you to think about it a little bit. What do we know? We know that it repeats every 4, right? Here's how I look at it. If I have a number that divides evenly by 4, it's always going to be 1, right? 8 divided by 4 is 2. I have an even number. It divides evenly. We're going to get 1, right? If I have no remainder, think about it as a division problem. If I have no remainder on the problem, so let's say if I wanted I to the 12th, if I divide this by 4 and there's no remainder, my answer is going to be 1. So 4 divided by 12 is 3, and that equals 12. 0 remainder, the solution is going to be 1. If I have a remainder of 1, it's I. If I have a remainder of 2, it's negative I. And if I have a remainder of 3, it's negative 1. And if I have a remainder of 3, it's negative I. So if we have I to the 27th power, we're going to take the power, 27. We're going to divide it by 4, right? 4 goes into 27 6 times, right? Which makes 24. And I have a remainder of 3. That remainder of 3 means that the solution to this one is negative I. If I do 112 divided by 4, 4 goes into 11 2 times, which gives me 8. That's going to give me 32. 4 goes into 32 8 times, which is 32. I have a 0 remainder. So this is going to be 1. 278. I don't know. I don't know what 278 divided by 4 is. 4 goes into 27, though, again with, 6 times? And that gives me 24, which is a remainder of 3. 38. 4 goes into 38 9 times, which is 36, giving me a remainder of 2, which means that this equals negative 1. Does that make some sense to you? You don't really have to do much with this. There's a couple problems in the homework with it. What it does allow you to do, though, is to kind of figure out pretty easily what I to any power is going to be. It's always going to be one of these 4, right? If it divides evenly by 4, it's going to be 1. If it has a remainder of 1, it's going to be I. If it has a remainder of 2, it's going to be negative 1. If it has a remainder of 3, it's going to be negative I, right? So when you divide, it's how many are left over. Does that make some sense? I'm going to put you to the test on it right now, because I'm going to ask you guys to find me I to the 49th power. When you get it, put it in the box. We'll see if you're right. Everybody should answer. It's going to be your attendance question right now. So if you don't answer it, you're not here today. I should probably figure it out myself. Okay. So you can only have 4 answers, right? It's either going to be I, negative 1, negative I, or 1. Just take the power and divide it by 4. If it divides evenly, it's 1. If it divides and you have 1 left over, it's going to be I. If you have 2 left over, it's negative I. If you have 3 left over, it's negative I. And you're not being graded right now on whether or not you get it right. You're graded on whether or not you answer it right now because it's going to be your attendance, whether or not you answer it. But I want to get a general feel of what people think. It depends on the number you have left over. If you have one left over, it's I. If you have two left over, it's -1. If you have three left over, it's negative I. Look at the power up here. Anything that divides evenly by 4, right? Anything that divides evenly by 4, you're going to get 1. Anything else, if it's 1 remainder, you get I. If it's a 2 remainder, you get negative I. If it's a 3 remainder, you get -1. If it's a 3 remainder, you get negative I. A lot of I's in there. Adam gave me an IDI. Let me know when you all have your answer in. I guess you can't let me know. I have to look and actually see. So here we've got 49. And if we divide that by 4, right, it goes into 4 one time, right? 0. Bring down the 9. 4 goes into 9 2 times, which is 8. And we have a remainder of 1. So the I's have it. Excellent job. The only other thing we have to talk about is products. What did I say that I times I equals? Or I squared equals? -1, right? Excellent. So anytime, say we're multiplying, say if I have 4I times 7I, I can just multiply 7 times 4 and I have 28. When I multiply the I times I have I squared. And that's just going to give me -28. Because if you think about it, this is like saying 28 times -1, right? Which just equals -28. Anytime you have an I squared on the outside of anything, when you get rid of it, all it does is change that sign in front of whatever it's being multiplied to. So if I have -4I times 2I times -9I, right? Let's look at this one. We've got 2 times 4 is 8, times 9 is 72. It's going to be positive, right? 4 times 2, -4 times 2 is -8, but -8 times -9 is positive 72. And then we have I times I times I, so that's I cubed, which we know that I cubed is just -I. So this is like saying 72 times -I, which is just -72I. So it's mostly treated like a variable, as long as you know that that I squared just gives you -1. If I have 2I cubed, let's put that in parentheses, 2I cubed times 5I. When I apply this cube to the 2I, I have to apply it to the 2. 2 cubed is 8. And I have to apply it to the I. right? And then when I multiply them together, I can go 8 times 5 is 40. And then I can go, well, that's I to the fourth, which we know is just 1. So that is going to equal 40, right? Because we know that 40 times I to the fourth is like saying 40 times 1, which is just 40. Trying to look at things that might be complicated when you get to them so that you can see how to solve them when you get there. But really, that's kind of it. Do you guys remember how to handle something if you have like the square root of negative 18 times the square root of negative 10? Do you remember how to combine those in terms of multiplying square roots times each other? All you would do is keep them under the square root, and you can make it negative 18 times negative 10 underneath there, right? Um, Actually, with an I, before doing that, I would pull the I out first. So I would go, this is I times 18 times I times 10, right? I would pull the I out first. And then go, we have I squared times 18 times 10, which is I squared times 180. And you'd have to break that down. I would look at that as what? Trying to think of the best way to break it down. 180, I would go, well, it's 2 times 90, which is 2 times 45, which is 5 times 9, which is 3 times 3. So technically we pull out 3s, we can pull out 2s, but we can't pull out the 5. And so we have 2 times 3 is 6, I squared times the square root of 5. But that I squared is negative 1. So it just becomes that all this I squared does is change the sign right here. So it becomes negative 6 times the square root of 5. So play with them a little bit. Make sure and show your work on them. Like I said, I will be in tutoring hours today right after class. This worksheet will be posted as soon as I'm done. I haven't posted it in there, but it's ready. I just need to pop it into PowerSchool. Any questions pertaining to this? Is there anything that we did that you don't understand that you'd like to see a little bit more of or practice with? What kind would you like to see, Race? Of the multiplication ones or the square roots? Like the one I just did? Okay. Do you like it with the multiplication, or do you want it like the one in blue or the one in orange? Anyway, let's try. Let's do kind of a combination then. Let's look at if I have the square root of negative 24 times the square root of negative 3 times the square root of negative 2, right? I can pull each of these out as an I, right? I can go I times the square root of 24 times I times the square root of 3. Sorry, I forgot the I on this one. times I times the square root of 2, right? And when I put all those together, I'm going to have I cubed, right? I'm going to have I times I times I. I'm going to have I cubed, and then all of these will be underneath. 24 times 3, 75 minus 3, 72. 72 times 2. What is 72 times 2? I believe it's 152. Ooh, that's convenient. 152. No? Is it 152? No. It's 144. Oh, that's way better. 144 is way better. What is the square root of 144? What times itself gives me 144? Excellent. So right now I have 144. I'm sorry, I have 12 I cubed, right? Let me rewrite it so it's pretty. I have 12 I cubed. And we know from our little chart before that I cubed, wow, our chart's really far up there. The I cubed just equals negative I, right? So I can go ahead and substitute that as 12 times negative I, and I would just be left with negative 12I. I highly recommend when you do it, make sure you're looking at that little chart of what they can be, right? Because it really helps. The video of this I will upload to PowerSchool as well as the assignment. Oops.